Okay, welcome to the British Geological Survey Virtual Open Day 2020. My name is Clive Mitchell and I'm going to give you a presentation on pebble spotting. So just a little bit about me. I'm a geologist here at the BGS. I've been here working in Nottingham for the last 30 odd years, and my speciality are minerals. But along the way, I picked up a bit of a reputation as somebody to go for pebbles. So what I'm going to do, I'm going to share a presentation for 20 minutes. Then I'm going to show you a few of my favorite pebbles. And then maybe after that, we'll have some questions. And maybe you can share some of your pebbles with me if you have any pebbles. So let me just go to my presentation to start with. Oh, here we go. Pebble spotting by Clive Mitchell. That's me. Okay, so this is me. So this is my beginnings. Are very cute, exactly. So this was when I was about 5, and I first started collecting pebbles when I was a kid on holiday in Cornwall, and like a lot of people do. This was probably my first introduction to geology. And as a kid, I would pick up the pebbles. I wouldn't really have a clue as to what they were. So one of those things, you know, you pick them up and obviously it's the rule, you know, I basically as a 5-year-old, as a small boy, it's the law. You have to carry at least, among many other things, at least one pebble in your pocket. And that was me. And, you know, it didn't really go much beyond that, to be perfectly honest. And if we scroll forward 50 years, here is me a few years ago. And I was approached by a journalist by the name of Paula Kokoza. Now, Paula is a Guardian journalist, and this was in the end of sort of towards the end autumn 2016. Paula had been on holiday with the kids, and they booked a place, and they found a little leaflet, something like this, and they basically then started looking for pebbles on the beach. So that's what they did. They sort of spent most of their holiday collecting pebbles, and I suppose a little bit like me, picking things up because they were nice, they looked pretty, but they didn't really understand what they were. So from that point on, Paula thought, this is interesting. I've got hooked on this, and it's very likely that other people will be interested as well. So she decided to do an article on pebble collecting. So Paula got in touch with me, and we arranged to meet somewhere sort of midway from London, Nottingham. I chose Cromer, and this is Cromer Beach, and this is me with Paula on a reasonably dry, fine December morning, and we basically spent a couple of hours on the beach talking about pebbles, and Paula made loads of notes and then got the train back. And it took a little while, but the article came out in The Guardian in Feb 2017. Now, if you search for this, if you search for No Stone Unturned, my search for the Pebble Hunter Holy Grail, this is still online and you'll find this. And some of the things that I'm going to talk about today are covered in that article. And this is something that Paula added to the article, which I think is quite nice. And it's still true. Pebble hunting is what geologists do on holiday, which does sound like a bit of a busman's holiday. But I'm basically somebody who, when I go on holiday, I like to pick up pebbles and try and work out what they are. And mostly I can. Sometimes when they're pebbles like this, where they're a little bit harder to work out, but you can't quite see what's going on. So I decided to do a little bit more pebble collecting. So in 2017, I started collecting more pebbles. And in the back of my mind, it was something like, you know, one day maybe I'll do something maybe for the BGS, maybe a little booklet, maybe something online. So I collected pebbles, and every time I went on holiday, I would collect a few pebbles from the beach in lots of different places around the country. And as a professional geologist, like I said, I know what they are and the best way to collect them, because I'm a minerals geologist, and one of the things I do, I go out into the field and collect rocks and minerals and try and work out what they are. And I'm an industrial minerals geologist, so I try and work out what they may be used for. So for example, something like limestone for cement and other minerals for different other applications. And over the last 4 years, I've amassed about 6 sort of boxes, sort of medium-sized boxes, sort of photocopier paper box sized boxes full of pebbles in my office and one at home. quite a few of the pebbles at home are actually relegated, but these, I still have some in the sort of makeshift home office I have at home. And then out of the blue, a company called Pavilion got in touch with me, and they are a publisher for the National Trust. And they commissioned me to write a book on pebbles called The Pebble Spotter's Guide. My pebble collection turned out to be absolutely perfect for this. And if you're interested, this is the mock-up of the cover. If you Google The Pebble Spotter's Guide and Clive Mitchell, you'll find me. You'll also find it on Amazon for pre-sale, even though it's not coming out for a little while yet, April 21. So here we go. What is a pebble? Well, this isn't a technical definition. This is my definition of what a pebble is. And basically, a pebble is a smooth rock that fits neatly into the palm of your hand like this. So inevitably, it means that if you've got a small hand or a larger hand than mine, your perfect pebble will be smaller or larger than mine. So they don't all have to be this size, but it's something tactile, something nice and pleasing about picking up a pebble and just holding it in your hand. It's quite a nice thing to do. So here we go. This is a pebble I collected on a recent trip to the beach. I think this was a place called Anderby Creek, which is on the east coast of England. And as always, I'll be picking up more pebbles as I go along. And so what are pebbles? Well, pebbles can be made from lots of different types of rocks, such as granite, limestone, and sandstone. And don't worry, I'm going to show you some of these things as we go along. But also, they can be made of other things. So they're not all naturally occurring materials. Some may be artificial, like glass, concrete, brick, or tarmac. Sometimes these can be hard, even for a professional geologist, to work out whether they are artificial or natural. So it's actually quite hard sometimes to work out what they are. So this was quite a surprise to me. Who actually invented pebbles? Well, cast your mind back, maybe you're not this old. Queen Victoria, the first time she went to a beach, this was in July 1847, and she used her bathing machine. Now, if you don't know what a bathing machine is, picture a beach hut on wheels, which is then wheeled down to the sea on a private beach on the Isle of Wight. And her first impression of the beach was she thought it delightful, but found the beach a bit boring. So she got in touch with a very famous Victorian sculptor by the name of Henry Cole, and he produced the first ever pebble in 1850. And actually, coincidentally, it's the 170th birthday of pebbles today. Who would have thought? Obviously, that's silly. I've just made that up. It's nothing to do with Queen Victoria or John Henry Cole. It's actually all down to geology. And I'm a geologist, you would have guessed. So, where can I find pebbles? Well, I think most of you can probably give a good answer to this. But you can find pebbles in rivers. So they often start their life in rivers, traveling down from the mountains and hills down to the sea. Lakes. This river may then pass through a lake, and a lot of the lake pebbles that you find may come from rivers that feed into the lakes on the way. And then the beach. Well, the beach is where you find a lot of pebbles which may have come from that river, but also from the rocks that may form the cliffs that you often find along the coast. In addition, you may find pebbles on land as well. So you may go for a walk, a farmer's field, your garden, the local forest. You may find pebbles occur in the soil. And this is because the geology, the rocks under the ground, contain pebbles. So you can find them, they don't have to be on a beach. So you do find them in all sorts of different places. So if you're landlocked, it may be that there'll be somewhere near you that you can actually go and do some pebble hunting. So how are pebbles made? Well, this is an interesting geological explanation. They basically start off their life as rocks. And rocks, they may occur in mountains and hills, and then basically cracks and fissures and in the rocks are broken up by the action of things like ice, rain and heat, and they break up the bigger rocks into smaller rocks. And this is the act of erosion. Weathering and erosion then breaks these rocks down, and the water then washes them into streams and rivers, and the rocks are then transported down. So the pebbles are washed down the hills and mountains to the sea. So the process of forming the pebble itself, the actual rounding process, is due to pebbles basically bashing into each other as they make their way down. And this is known as attrition. This is basically where all the sharp edges and corners of the rock are bashed off. And this process is completed, whoops, and this process is, it says there, it says this process is completed on the beach. So when you're on the beach, as you saw, if you saw my little video before this presentation started, the backwards and forwards washing of the pebbles on the beach, continually rubbing these rocks together, rounding them. Ultimately, it will not just round them, it will destroy them, and they will then be replenished by other beaches. So this is where sand comes from, because that's what basically sand is a tiny pebble. So this is an interesting question. Yes, I know, because I wrote it, and it's a question that I've been asked before. Why do some beaches just have sand, and some beaches are just pebbles, and then some are a mixture of the two? Well, one of the explanations is that some rocks are very hard, and they survive all the way to the beach, and they last a long time on the beach. Other rocks are very soft, and they break down readily. So you will often find the fact that there are no pebbles on that beach because the rocks that fed onto that beach were very soft, and they then form the sand, and the silt and the mud that gets washed out to sea. And the local geology has a role as well. So basically, some places have hard rocks and others have soft rocks. So for example, this picture here, you can see here is the chalk. And the chalk is a white, crumbly limestone. If you touch it, the whiteness comes off on your fingers. And it's very, very, it breaks down very quickly. But even chalk pebbles occur on beaches. They may not last very long because they're very fragile, but they will, as you can see in this picture, occur on the beach. If you go to these beaches, what you'll often see in the sea can sometimes look a little bit milky white. And that's because the chalk has been ground right down to mud, and it's been washed out to sea as a sort of lime mud, as a sort of chalky mud. So here we go, some tips on finding pebbles. Now, where are you going to go? I suggest we go to the beach. The beach is a great place to look for pebbles. So what I like to do, sometimes you'll see me walking up and down the beach with my head down, scanning away, looking for the interesting stuff. That does work sometimes. What I suggest is a better way of doing things is to sit down in a patch of pebbles and pick up every single pebble around you and just look at each one of them and see if there's anything interesting. And then sometimes that patch of pebbles may have a layer of pebbles underneath. And if you remove that top layer of pebbles and look underneath, that's where sometimes you'll find, so if you have two big pebbles like this, that smaller pebbles like this one slip between the two pebbles and they sit underneath. So actually, you might find some really interesting little pebbles like this one tucked away underneath the bigger pebbles. Because often you'll find that these bigger pebbles are a bit big and boring, and all the sort of interesting stuff, like this one, which is quite an interesting looking pebble, will be nestled away underneath those pebbles. So take your time. It's actually quite relaxing, sifting pebbles, I find. The other thing I suggest you do if you go on the beach is take a hand lens. Now, this photograph shows you a hand lens. And I'll show you how to use one of these after the presentation, because there's a bit of a knack to using one of these. And it's a bit like a magnifying glass. And you can get them quite cheaply if you look on the internet, on Amazon or wherever, and you can get them quite cheaply, maybe for only a few pounds. And if you've actually signed up for the talk on Saturday and you've got the rock kit, you will have one of these hand lenses. So maybe dig out your hand lens now, and I can show you how I would think is a good idea of using a hand lens after this talk. So, and I don't know everything, so I always carry a little guidebook with me as well, because there are tons of different types of rocks and tons of different types of minerals. And sometimes it's hard to work out one from the other. So I've got a couple of recommendations at the end of this presentation for books that I recommend and I've used in writing my book. And you are allowed to take pebbles from the beach, and take a cloth bag with you, maybe something to store them in. I often use little plastic bags like this. They're not single use because I'm keeping these pebbles, so they're actually used as storage devices. And I tend to try and separate my pebbles out, because if you have a bunch of pebbles together in a bag, they will carry on bashing each other, and they get scuffed and they're not being washed by the sea, so they're not dusty. And I know that from experience, you'll end up with a bag of dusty pebbles. So I think, this is, and the other thing I would say is you don't have to take all the pebbles with you. I mean, you take half a dozen, that's fine. Take photographs of the ones that you leave behind. And that's a good way, and you might like to share those, show them to your friends, show them to your colleague, and maybe you can just use that as a record. And what I would also say is, on the bag from that beach, write down the name of the beach and the name and the date that you collected them. This will help you remember where that pebble came from. So if you're serious about collecting pebbles, this is a good way, because pebbles can look very similar when you get them back home, and after maybe a couple of weeks, it'll be very difficult to work out where they came from. So, health and safety. There's always a health and safety bit in a presentation, it seems. And I think this is important. So, I recommend that you stay away from cliffs, as rockfalls can happen, especially after wet weather. What happens is rocks can fill up with water and they become really heavy. If there are any cracks in the rocks, the water, the heavy rocks can then pull away from the cliff. So it's very careful. You have to be very cautious when you're around cliffs. Follow the warning signs. You will see warning signs at the beach, especially where there are cliffs. And this little sign on the left-hand side is a typical warning sign from a beach. Beware of the tide. It can easily be cut off if you're not careful, and that's happened to me. I've not been cut off, but nearly, and I've got wet feet as a result, wet shoes even. Beware of steep beaches. Some beaches have quite steep beaches, and quite energetic waves that come into them. So watch out for that, because you don't want to be knocked over. And I'm a geologist. I have a geological hammer, but I'm not a great fan of just hammering into cliffs, because you might, looking at the first point, cause rocks to fall on your head, and also you'll cause damage, and it can be dangerous. If you do want to use a hammer, a geological hammer, then wear some eye protection. So here we go. These are my goggles, my eye protection, and I'll probably wear gloves as well. So I basically do this to protect my eyes. I can't see anything now because I take my glasses off. So this is to protect you, but also to protect passers-by, because if you hit a rock with a hammer, obviously you've got to watch out for your fingers, because I've done that as well, but also little sharp shards of rock will splinter off and ping off in all directions into your face, maybe hit your sister and your brother and your mum and dad and passers-by. So we want to avoid that. So it's not a good idea, really. But if you are going to do it with a grown-up or with somebody responsible, and just watch out, just be sensible. So we've come to more or less the end of my presentation. This is the first part of today, and I've got a couple of books here that I recommend, and the one on the left is part of a series of books that Dorling Kindersley do, and this is one of the best books I found for identifying rocks and minerals. The book on the right, the illustrated guide, is a bit more advanced, but this is also very good because it goes much more into the classification of rocks and much more about the geology. So there you go. I'm going to stop sharing this presentation now and come back to here. There are a few other guides that I recommend as well. So for example, you often find guides like this. So this is about things you'll find on the beaches in Yorkshire. And this is really nice because it shows you quite a lot of different types of pebbles, if you can see that. This is actually, doesn't cost very much, it's only a few pounds. The other one I've got is a little one like this, a little leaflet. You'll often find, in fact, if you Google this, you'll actually find this on the internet, I think. So you can actually send off for this one. And a few years ago, B just did a really nice one. I'm not sure we even produce this anymore, but it's a really nice sort of booklet that we produced a few years ago. You can see lots of different types of pebbles in there. So that's a really nice one. So there we go. So what I'm going to do now, I am going to show you how to use a hand lens, and I'm going to use this piece of rock here. So I'm going to tell you what this is. I suspect many of you will know what this is. You can see, I'll give you a clue. It feels quite rough. It feels quite sandy. That's a very strong clue. And this is made from other rocks which have been broken down into sand, and that sand has been cemented together to form a stone. In this case, it's called sandstone. So this is actually quite common, this type of rock. Not all of them are as sandy as this. This is also a sandstone, but you can see it looks much smoother, and that's because the individual grains of sand are finer, they're smaller, and they've been glued together, cemented together. and it makes it very, very hard. This is much harder than this one. This one is a little bit crumbly. So what we do, we can take our glasses off because we've got a hand lens, and a hand lens is a magnifying glass. So let me just put it on again just to show you. Now, often what people do with a hand lens is this. They try and use it like a magnifying glass. So they try and you can see a little bit like that. And you know, you would think that's how you use a magnifying glass to magnify things. Okay. However, the best way to use a magnifying glass is like this. Make the hand lens right up to your face, literally so the hand lens touches your eyelashes. And if you do that, bring it right up, you can then see all of the grains of sand in the sandstone. It's actually one of those, ooh, wow, look at that moments when I show this to when we do things in Science Week, and we have kids looking at rocks, and they can see all the grains. Now, this particular hand lens has what it calls a 10x. Well, that means 10 times. So what you see through this hand lens is 10 times the magnification as you would use with your eye. So you're seeing things 10 times larger, and that enables you to see things much easier. And this one, experience tells me this is a sandstone. But if I was trying to work it out from first principles, I know that a sandstone, as I said before, is made from other rocks like granite, which I'll show you in a minute, which have been broken down into sand, and that sand has then been deposited, maybe in a river, lake, or a beach. And over time, that sand has been buried, and that sand is then formed into a rock like sandstone. And you can see layers in this rock, and they may be sedimentary layers. This one's quite an iron-rich sandstone, so you can see a lot of iron in here as well. So it's rusty red colour. Not all sandstones have this really rusty colour, and this is quite nice. I picked this up from a beach in Hornsea in Yorkshire. So it's quite a nice. This is quite a nice piece of rock. What I'm going to do now, I'm going to talk you through a few more rocks, and I mentioned granite. Well, here we go. I've got a couple of pieces of granite here. Now, the nice thing about granite is you can see really big crystals, even without a magnifying glass, without a hand lens. Now, a granite, and I suspect some of you know this already, you may find this sometimes in the house, in the home. I'm sure Leanne will talk about that on Saturday. And it's an igneous rock. Now, igneous rock has been made from molten material, so rocks that have underground which have melted. And in this particular case, that molten rock, that magma, has cooled underground. And as it cools and cools down, and the heat leaves it very, very slowly, the crystals will start to grow in the magma. And what you see here, you can see a variety of different minerals. So if you can see that sort of like rectangular pinkish one in the middle there, that is a piece of feldspar. And you'll often see other paler, maybe whiter rectangles in here. And that's another type of feldspar. You'll also see some sort of grey, glassy looking, smaller crystals, quite crystalline, and that is quartz. And some of the dark minerals in here, you'll often see things like mica, biotite mica, and other minerals. So this is made of a variety of minerals. And like I said, if you took this apart into the individual minerals, you'll make a sand. This is a different type. You can see this is got much, it's a bigger pebble, and it's got much coarser, and it's mostly made of feldspar and quartz. And you can see here, you can see the sort of glassy looking stuff, the grey stuff is the quartz, and the white stuff there is the feldspar. So you know that this is another piece of granite. So you get lots of granite in this country, and you'll find these because they're quite hard, and they resist, they don't break down, and you'll find them on the beach. Other rocks that I have, now I have a whole variety of rocks. These rocks here, and these are also igneous rocks, but these are igneous rocks that have erupted onto the surface of the planet. So that is called lava. So these have come from volcanoes, and you get this interesting, and these particular lavas have got crystals in them. So I've got three different types here. This particular one is a very common igneous rock known as basalt. And what you can see here, these little round little round blobs. And these little round blobs are full of white crystals. And what happens, igneous rocks like lava will often have bubbles of gas in them. And that bubble of gas tries to escape, tries to rise to the surface and tries to escape from the lava. The lava is cooling down, and it's a big difference to the granite. They're both igneous rocks, but you can see much bigger crystals than this one. This one's dark, but it has tiny crystals in it. What happens is this cools much more quickly. That bubble of gas sometimes doesn't escape the rock. It gets frozen in the rock as a little, what we call a little vesicle, a little hole. And that hole is where the bubble formed and got trapped in the rock. And over time, that hole gets filled with white crystals. There's a name for that, and their vesicle is the name of the hole, but amygdale, A-M-Y-G-D-A-L-E, is the name of the vesicle filled with crystals. So this is an amygdaloidal basalt. So that's actually quite a nice one. This one is another type of lava. It's different to this one. It's much lighter in colour, and this one is sort of a porphyry. Now, a porphyry is a lava with crystals in it, so a rock, fine rock with crystals. And you can see white crystals of feldspar, but also what's really nice about this one, it has very tiny, it might be hard to see on the screen here, very tiny grey glassy crystals of quartz. So this is quite a famous, it's called a quartz porphyry, and I got this one on holiday a couple of years ago on Arran. And quartz porphyry is quite a famous lava. And this last one, this of the lavas I can show you, this is a nice one. And you get this one on a lot of the beaches along the east coast of England. And this is known as a rhomb porphyry because those crystals of feldspar that you can see here have a sort of diamond shape. Maybe not the best example here, but you can find examples of this rock on lots of beaches. And an interesting story with this rock is the fact that these porphyries have come from one place in Europe, and that's just outside Oslo. How on earth did it get to the east coast of England? And the theory goes that glaciers picked up the rocks from Norway and carried them over the North Sea and deposited them in the glacial deposits on the east coast. And those glacial deposits then are weathered and release the pebbles. And this comes, that's the theory, from Norway. And I've been to that quarry and I have got examples, fresh rock examples of exactly the same material. So there you go, there's two different types of rock there. This is an igneous rock, and our sandstone is known as a sedimentary rock. And sedimentary rocks, as I said before, are made from other materials. So they're things like sandstones. Another famous one that you'll recognize as well, this is a nice one, this is called limestone. And limestone is made from what's left behind when animals die. So in the sea, for example, you might have seashells, they die, and the soft parts are rot away, and you're left with the shell. And those shells get crunched down into sediment, and they can form, if there's no other material in the sea, they can form a thick layer of crunched up material. If you look at this one carefully, you can see it's almost 100% shells. This is a really nice example. In fact, I picked this up from Clevedon in North Somerset. This is not far from where I grew up. And this is so full of fossils. There's a special word that we use as a geologist. We call this fossiliferous. Fossiliferous just means full of fossils. So that is a fossiliferous limestone. That's really nice. And I have another one. Here we go. This is another nice one. And this one is basically a limestone with another type of fossil in it. But you can see all those dots, and those dots are the ends of tubes which go through the rock. And this is actually a fossil coral. So this has come from a time when coral grew in the UK, and it's formed a limestone. So this is basically a frozen coral, frozen in time. Other rocks that you find in the UK which are quite common, this one is a flint pebble. Flint is a very, very common pebble that you find. It occurs as layers within the chalk. And if you break this open, you'll find that inside it's dark. This outside is sort of white crust. And they can look like all sorts of things. But flint is a very, very common pebble that you find in the UK. Other common pebbles that you find as well are these types of pebbles, and you can see they're you can almost see light through them. They're a little bit translucent, which means that light will shine through them. And these are pebbles of pure quartz. And this may have come from a quartz vein. So if you get a big crack in the rock, you'll sometimes find that it fills up with silica, with quartz, and you get these pebbles eroding out. I really like these because they form really lovely, smooth, nice pebbles, very tactile, very lovely. Now, that's two different types of rock. And now the third type of rock is known as a metamorphic rock. Now, this one here is one of my favorite types of rock. And if you look at that, you can see how amazingly shiny is that. This rock is known as a schist. Carefully say that, S-C-H-I-S-T. A schist is a metamorphic rock, where a metamorphic rock occurs where other rocks, like sedimentary and igneous rock, have been changed. And the minerals have been recrystallized into other things. So you basically get from intense pressure or intense heat. And those two things act to change the rock. So for example, this rock may have been buried under a mountain. You can imagine the pressure with a mountain on top of your head. And what happens is this may have started life as a rock known as a mudstone, which is basically mud into stone, a bit like sandstone into sandstone. And the minerals in the mudstone are recrystallized to form a mineral called mica. And you can see that's what makes the shiny surface here. And because it's been squished, basically the mica grows in flat layers. So that's why it's so shiny, because it's layered out flat. And actually, if I rub it hard enough, the mica will come off on your hands, but it's quite a weak mineral in this direction. So that's a really nice one. So that is called a mica schist. So we give the name of the main mineral to the rock. So it's a mica schist. If it had other minerals, we might call it a garnet mica schist. If it had garnets in it, and garnets are little red dots that you sometimes see in this. So if you find one with garnets in, that's a really nice. I really like that. That's one of my favorites. So this is another rock, which is a very famous one. And this is known as a gneiss, not N-I-C-E, it's G-N-E-I-S-S. A gneiss is one of the oldest rocks, and I got this from the Highlands of Scotland. And this rock forms from either things like sedimentary rocks like sandstones or from granites. So this one possibly came from a sandstone. This gneiss possibly came from a granite. And this famous rock basically is probably one of the oldest rocks in the UK. And we're talking over 1 billion years old. And it forms what we call the basement or the bedrock of the UK. And this is one of the founding rocks of the UK, which all other rocks sit on top of. So it's a really, really nice rock. And here we go. Just to round off on my pebbles. What do you think this is? It's sort of reddish brown. Here's another example. A little bit more of a giveaway. It sort of has a familiar look about it. Here's another example. It's sort of funny feel to it. It doesn't feel as heavy as a rock. And it has a brick red. Oh, I told you. There you go. Yes, as I said before, you will find artificial things sometimes which look like this. You might confuse them for maybe a sandstone or maybe a lava even sometimes. This is a brick. And what's happened is bricks have found their way onto the beach because maybe the cliffs have collapsed, maybe a house or a wall has fallen onto the beach, and the bricks have then rounded like a pebble, and basically that you then find these on the beach, and you find them in quite a lot of different places, as well as pottery, glass, concrete, all sorts of tarmac, all sorts of things that I picked up over the years from a beach. These are actually quite common. So what else do we have? Okay, so, and just a last one, just a nice little one. This is a nice one I picked up from the beach. It's only a tiny little thing, and this is the end of something called a belemnite, and you'll find this on the beach in some places. Here's a little fossil sea creature, and this is the nose cone essentially of a sea creature, which then was much bigger. And you often find these, and sometimes you'll see them in the rocks. They have this sort of like radial appearance here with little lines coming out from them, so you'll see those sometimes on the beach. So there we go. I think that's sort of like covers me for pebbles. Eloise, shall we have a think about some questions?
Yes, we've got a couple of questions that have come in. So one that was emailed into us earlier is quite a good one. Is it wrong to take pebbles home from the beach? If everyone did this, there'd be none left, surely. But fossil hunters say it's okay to take fossils from the beach because otherwise they would get broken up and dissolved by the sea.
Oh, that's a good question. I spoke a little bit about taking, so I've got my pebble collection. I've obviously brought them home from a beach. Now, it's not entirely clear, but this is my understanding that it's okay for you to take some pebbles from the beach. So maybe, you know, half a dozen even maybe, but no more than that really. So that's fine, and that's absolutely no problem. You have to watch out though, because in some places, some beaches are governed by local bylaws. So it's illegal to take, well, I'm not sure it's illegal, but it's frowned on, basically. The locals don't want you to take beaches from that particular beach. So there are some places where they're worried that if you remove the pebbles, it may lead to further erosion of the cliff. Because if you remove pebbles from the beach, it might then encourage the sea to come closer to the cliffs. And some places, the cliffs are being washed away very quickly, and people are worried that their house will fall into the sea. So there's that concern. One thing I personally frown on is people taking pebbles from a beach and then selling them. Now that sort of transgresses and that moves into mineral extraction. And in this country, if you are a quarry or you have an operation where you sell minerals, you quarry the minerals, you have to have a planning permission from the local authority. And you won't get that for a beach. This is an active, this is basically for conservation, for environmental reasons. And you'll sometimes see people selling pebbles, and I do have to wonder where these pebbles have come from. And I'm not keen on that. And I think, you know, it's not done on sometimes you hear of places where people have gone away and taken a wheelbarrow full away or a boot full of pebbles, and that's obviously for commercial reasons. But if you're not doing it for commercial reasons, if you're just purely collecting pebbles for your own pleasure, then that's absolutely fine. I think that's great. I think it encourages you to get interested in geology, which is fantastic. Okay, Eloise, do you have another question?
I'm just looking through the Q&A. If you have got any questions, if you could post it in the Q&A, that would be a little bit easier for us to go through. Thank you.
We've got a few things in the chat here, Eloise.
I'll just go through the Q&A first, just as a little bit easier for us to answer live. Okay. So the next one, can pebbles travel across the oceans through traction and sanitation? I have found, yeah, that's one. I found a lovely green pebble with a waxy finish that looks like jade, but I found a beach on the southern Greek island, so logically it can't be.
Oh, there you go. Okay, that's interesting. Now, in theory, pebbles can travel. It's unlikely that pebble is going to travel intercontinentally. It's not going to travel across the oceans unless you put it in your pocket and you travel and take it on a plane or something. One thing that you often find, though, is that in some places you'll find exotic rocks that don't belong there because those rocks have been used for coastal protection. So what you'll find in certain parts of the UK on the coast, you might find that they've taken rocks from Norway in massive big blocks and put them on the coast. Those rocks will gradually break down over time. So sometimes you'll find that those have been brought in deliberately to protect the coast. So actually, it's a really interesting dilemma because you'll find some really interesting, there's a rock called lavakite, which is a really nice sort of purpley shiny rock that you sometimes see in shop fronts. It's got a particular type of feldspar that's very shiny. But that comes from Norway, and they've been brought big blocks over, and you'll sometimes find pebbles of that on the beach because it's come from the coast protection blocks broken down. Okay, here we go, Eloise. Here's the next question. Yeah, shall I read it?
Yep. So the next one is: what makes some pebbly beaches have more varied pebbles? Is this to do with the currents around Britain? I believe that Fletswick in Cumbria has a variety of pebbles, but I don't know why.
Interesting. No, I think as I said before, sometimes the variety. Now, the East Coast is really interesting because a lot of the pebbles you find on the beach there have come from the glacial deposits. Now, back in the Ice Ages, glaciers covered most of northern England, and a glacier would, at the bottom of the glacier, would pluck up rocks, it would freeze onto them and pluck them up, and then act as sort of scouring, and it would then build up a layer of mud. And when the glacier melts, this mud is deposited as a glacial deposit full of pebbles. These pebbles can come from a huge variety of different rocks across the UK, and they're all found on the coast. So a lot of the pebbles that I'm showing you might have come from those beaches. So it's difficult to say exactly where the pebble came from, because it's come from that glacial deposit, which has then used the UK as its backyard, as it were. So it's that's an interesting question, and you're absolutely right. You do get a really interesting variety of pebbles, and this is where, you know, I travel the UK trying to find that variety. So let's go for the next one, Eloise.
Thank you. So another one is kind of similar to one we've had before, but is it legal to bring pebbles back from overseas in small amounts?
Good question. That very much depends, like I said before, on the local laws. I can't imagine that would be a big problem. It may be that you might run foul of some local laws, but I would imagine if you're talking about one or two small little pebbles, I can't imagine that being a problem. But I can't be definite on that, because, you know, like we have in the UK, we have lots of local bylaws, lots of little local areas which may have different rules. So yeah, I would say that's one it's not a risk as such, but I've heard of instances where things like that have been confiscated. Okay,
so another one. How long does it take for a rock to become a pebble, and how do you know the age of the rock?
Oh, that's a good question. Now, interesting, because the pebble may have been on the beach for a very short time. So, for example, that picture you saw of the chalk, that is a very fragile rock, and I would imagine that pebble would not last very long. It might only last months on the beach. It's come from because it's a soft rock, and I think that's one of the sort of, not a great answer, but basically it depends on how hard the rock is. So I can imagine a pebble, a rock starting in a mountain and being washed down to the sea. It's going to take quite a long time to gradually move its way down. It's going to take a long time. It might take years, it might take 10 years, might take 30, 40 years before it gets to the beach. On the beach, you've got the cliffs right there. And those pebbles, they're going to take years for them to be rounded down into pebbles. I don't know the exact answer to that, but I'm sure someone's done a scientific study on that. So next question, Eloise.
Oh, you have to forgive my pronunciation here. Can diorite and andesite
and andesite
found in the
UK? Yes, it can. And if you're interested in locations of specific rocks, if you go onto the BGS website, and there's something called the Geology of Britain Viewer, which will show you a map of the UK, and you can see every single rock in the UK, and you can search something called the lexicon, and this will tell you about all the different types of rocks and all the different types of geological formations in the UK. So that's a good place to start, really, is to go to the BGS website and look for the Geology of Britain Viewer, and this will tell you where some of these things occur.
So another one, I have found some beautiful serpentine pebbles from Cornwall. How is this formed?
Serpentine forms. Serpentine is a really interesting mineral, and we're talking about the lizard. And the lizard is an area of unique geology in the UK. And ultimately, serpentine is serpentine or serpentinite, which is the mineral formed from the mineral serpentine. There's a whole range of minerals that belong to the serpentine group of minerals. There's one beautiful one called lizardite from the lizard, and they are formed by other rocks being changed and altered. And those rocks were rocks that you would find deep under the ocean. And these are a bit like our granites, but they're sort of a different type of rock. Things like gabbros and ultra basic rocks, which have got lots of exotic minerals in them, and they've basically been changed. And serpentine has been formed from these minerals being changed. So what happens with that slice of ocean is, because of plate tectonics, where the crust in the ocean is moving around, if you imagine that's my continent and that's my ocean plate, sometimes a slice of ocean gets thrust up onto the land. And that's what's happened in the lizard. We've got a slice of the ocean, and we can see those minerals occurring there. So that's where it comes from.
Great, another one. I was thinking of making some pebble jewellery and selling them. Is this ethically okay? Would BGS frown on me for this? I'm asking for advice.
Deb, I think that is yes. That, as you could gather from my response to the previous question, it is a grey area, admittedly, and I would suggest that, you know, where you get these things from is the important thing, and you'd have to inquire locally. And like I said before, it's essentially mineral extraction we're talking about there. If you were actually gathering your own pebbles from a beach, then I think that's I think you have to be careful. I think you would probably have to take advice from the local authority, I'm afraid. Okay.
So, how is jet formed?
Oh, jets are really interesting. And I had a piece of jet. Now, jet is essentially fossil wood well, there's a little bit of controversy over this, and some people argue that it is or it isn't. But there is a tree called Araucaria, and that is commonly known as the monkey puzzle tree. Well, the sort of prehistoric ancestor of the monkey puzzle tree, back in the Carboniferous time, we're talking hundreds of millions of years ago, the wood from this tree has then been buried, and it forms layers within the rocks, and you can find them Carboniferous or Jurassic. Anyway, you can find them. The classic place for finding jet is Whitby. Whitby jet is famous, and the Victorians Queen Victoria made Whitby jet famous when her husband died, and it was a sort of stone for mourning. It became very fashionable. It no longer is. So yes, it's fossil wood. Always. Okay, Eloise, off you go. Next one.
Where do most beach pebbles come from? Is it weathering from local rocks, or do they travel along the shore from other locations?
Well, I think you've answered your own question there. Yes, it's a combination. As I said before, there'll be some pebbles that have come from inland. They may have come from glacial deposits, from rivers, but also from local cliffs. But you're absolutely right. We have this thing called Longshore Drift along the UK, which sort of works its way up the coast, and down the coast on one side and up the coast on the other. And pebbles will then migrate along the coast. This is why some resorts have these wooden barriers, these groins that they put on the beach to stop sediment from moving, because it's continually shifting and moving around the coast. So yes, you're absolutely right. It is from weathering, it is from breaking down of local rocks, but from it's a combination of all sorts of things. Okay, Louise, the next one.
So, is there any chemical test that you can do to determine whether a pebble is a limestone?
Yes, there is a chemical test, a very, very simple chemical test. And it's not one that I would recommend. You'd have to be cautious, but as a geologist, what we would do is we would take some acid, some hydrochloric acid, diluted 10%, and we put a tiny drop of the acid on the rock. And what happens is acid reacts with limestone, which is made of calcium carbonate, and it generates carbon dioxide. You get little bubbles forming. If it's another type of rock which is associated similar to limestone or dolostone, it won't react. So you can tell if it's a limestone by very, very simply, but you'd have to be careful carrying acid around with you. Okay, the next one.
I have found a piece of
labradorite. Yeah.
Yep, on the beach, not far from Norwich. Is it something that can be found in the UK?
Well, there you go. This labradorite, this is what I was talking about earlier. This is the mineral, the shiny mineral that occurs in lavakite, which is the rock that is used in coastal defences. But certainly in East Anglia, I've seen it, and I suspect that's where it's come from. What is flint? Very good. Flint. There we go. Where's our flint? Flint is really interesting. You find a lot of flint in the UK, and this is made of the mineral silica, or the compound silica, SiO2. And the theory goes, and you can see a lot of this in layers in the chalk. You see lots of flint nodules in the chalk. The theory goes that this comes from the sponge spicules so the little silica spicules of a sponge, little spines of a sponge. And when the sponge dies, there's those spicules and other silica hard parts survive, and they coalesce when the rock is formed to form flint. That is the theory. I suspect there are people that would argue with that, but that is the theory that it comes from. It's essentially comes from a little bit like limestone, but it's silica. It's much harder than silica. Oh, here we go, Eloise. Shall I go for the next one?
Yeah, just keep going through them. We're getting quite a few through now.
How do I know that one is nice from sandstone and the other one was from something different? Good question. And there we go back to our two pieces of rock, and ultimately this is to do with the analysis of the rock. So somebody clever would take a very, very thin section, a very thin slice of the rock, and they would do something called Petrographic Analysis. So basically, you take a very thin slice. If you imagine you've got a loaf of bread, you slice it up. You get a very thin slice. The slice is so thin that light can be shone through it. So we can actually identify the minerals and analyze the minerals present. And this will then tell us the sort of minerals that we find in a sandstone or a granite. So I'm just guessing here, but this is how that would determine the two apart. That we'd have to do detailed analysis. But from that analysis in the past, we can make an assumption that these have a similar origin. Here we go, Eloise. So we've got one. Exploring an old lead mine in Derbyshire, a couple of 100 feet below the surface, we came across a deposit in the roof of mostly clay with some very round black pebbles the size of Malteser. I've never seen a deposit like this on land. How could it be formed, and where are the pebbles likely to be? Oh, that's really interesting. Without seeing the round black pebbles, I mean, pebbles do occur in rocks. So if you imagine the pebbles that we have on our beach here, if you imagine that in the future, this is then buried and it becomes part of a rock, you might be covered with sand, so you have a sandstone with pebbles in it. Sometimes that's where pebbles can occur because that sandstone can be ancient. It can be then buried and then be underground, very deep. So that's often where you would find pebbles. But in Derbyshire, I'm not sure what we're talking about here, whether we're talking about in the limestone or in the gritstone. It sounds like it possibly in the limestone. So what are the pebbles likely to be? I'd have to see them. I don't know. Or how does chalcopyrite form, and does it contain copper? Yes, chalcopyrite is a sulfide mineral, which is the mineral which is made of iron and sulfur, and yes, it does contain copper, and it's metallic mineral, and there's lots of different theories for how minerals like this form. I'm not an economic geologist like this, so I'm not entirely 100% sure, but email me afterwards and I can get you a better answer from someone who has a better understanding of how chalcopyrite forms. But it's basically a sulfide mineral that we find in, I don't know, limestones and other rocks like that. Do you have a favorite pebble, and where did you find it? Oh, that's a good question. That's a very nice question. I do have a favorite pebble, and my favorite pebble was a bit like the one I showed you earlier. It was a bit like this one, and it was the Ron Porphyry that I found when I was interviewed by the journalist Paul Kokoza. But it was a piece of Ron Porphyry that was about this sort of size. It was bigger and it fitted perfectly in the palm of my hand. And I found that on the beach in Cromer. Now, if you go to Cromer and you're looking out to sea and you're by the pier, if the pier is immediately in front of you, to your right, the beach is full of flint pebbles like this, covered loads of them. If you go to the left, the beach has only a few pebbles across the surface. Go left, because right, you're just going to see tons and tons of flint pebbles. Go left. If you're looking out to sea, go left. So the pier's there, go left. And you'll find all sorts of really interesting, you'll still see some of these, but you'll find some of these as well. You'll find lots of interesting pebbles. So that's where I found it. That was my favorite pebble. Unfortunately, I don't have it with me because it's with the publisher. Okay. Can you use white vinegar as a carbonate test? Good question. It is a weak acid. I've got a feeling I've tried this before and I have a feeling it didn't work. I think it was just too weak. But if you've got a piece of limestone, you could try it. A bit smelly compared to hydrochloric acid. So here we go. Okay, Eloise. So next one is, how can you tell the difference between a gemstone and glass? I found some small, clear, orangey stones on a Norfolk beach, which I was told were gemstones. If so, what might they be? Ah, well, now, it could be glass, but there's a mineral called carnelian, which is also a silica. But the nice thing about carnelian is it's clear. It's not clear. It's light will shine through it. If you've got one of those, I have been looking for a carnelian for years, and I've never found one. So you're very lucky. It is a semi-gemstone. It's not a precious gemstone, but semi-precious. So it's actually nice. So carnelian is a possibility. There are other varieties of silica type rocks similar to that one, which it might be as well. But carnelian is the one I'm looking for. So I'm very jealous if that's what you found. Okay, how many variants of quartz are there? Well, that's an extremely good question. Now, when you say variants, what you mean, I suspect, is the different colors of quartz that you get. And you can get clear quartz. So here we go. You can see that quartz can have different colors. And you can get very clear crystal quartz. You can get amethyst, which is a sort of purpley color. You can get citrine, which is a sort of brownish color. You can get smoky quartz, which is sort of gray color. There's a whole variety of different types of quartz, and it's probably, the list is probably as long as my arm. It's probably at least half a dozen, if not more. There are other varieties of minerals which are made of the same stuff, but if it's quartz, I think you're talking about the sort of color difference. So citrine, amethyst, smoky quartz, and others that I'm probably forgetting as well. So there's lots of different types of quartz. Okay, Eloise, is there anything else? Is there anything in there? Any other questions?
Just going to have a quick look through the Q&A, through the chat, sorry.
Here we go. There's one here saying, is agate a quartz? Well, agate is also made of silica, a bit like flint. And it's made of the same stuff. It's made of silica, it's SiO2, silica and oxygen. So it's a similar material. And yes, I think the theory goes that it's made of really, really, really tiny quartz crystals, what they call cryptocrystalline, which is so tiny that it's very difficult. You have to use a microscope to see them. You can find some beautiful veins through some pebbles. Is that quartz too? Yes, often it's quartz. In some cases, it might be calcite, and sometimes you might get other minerals, but typically quartz, calcite, the two. To tell the two apart, calcite is softer than quartz. There's something called the Mohs scale of hardness, MOHS, and that will give you the difference. On that scale of 1 to 10, 1 being talc, 10 being diamond, calcite is 3, quartz is 7. So if you get a little steel knife, you can scratch the quartz, but you can't the quartz.
It's got one more in the chat. So are there any beaches in the UK where we can find lots of gemstones?
Oh, that would be lovely, wouldn't it, to go to a beach and find gemstones. I would say that of the beaches that I've been to in the UK, I've got a little list of some of my favourite beaches that I would imagine. So, for example, I've mentioned Anderby Creek, Cromer, Mapleton, Caton, Runswick. These places are on the east coast, and these have a great variety of pebbles, and these pebbles have come from the glacial material. And there's also Carnelian Bay, which I've never been to, and maybe that's my mistake. I should have gone there to Carnelian Bay, which is up near Scarborough, and I should have gone there. So these are places I would say on the east coast that I don't think there's anywhere. I mean, you could argue that the beauty is in the eye of the beholder. So my little pebbles that I have at home, these are my gems. They're valuable to me, but I wouldn't get any money for them. So that's how I would view it.
Got a few more coming through the Q&A. I found some clear green pebbles on a beach on the Galapagos Islands. Could they be olivine?
Oh, yes, very likely. I think you're absolutely right, because I think that's a volcanic island, and you do get olivine crystals in basalt. So you do get them in basalt. So rocks like this, which I've got some from Lanzarote, when I went on holiday a few years ago. Fantastic, little sort of lovely green crystals. Perfect. If you find them yourself, I often say that the best pebbles are the ones you find yourself. And that's the value is the fact that you were on holiday, you're somewhere, it's a memory, it's a memento, it reminds you of the lovely time you had. It's also nice to have as well.
So have you ever found gypsum, and if so, where?
Oh, gypsum pebbles now, yes. Personally, no, but one of my colleagues, Gareth in Cardiff, has sent me some essentially gypsum pebbles, which is found on the beach in South Wales. The trouble is it's a very soft material, so it's going to break down very quickly, a bit like even softer than chalk. So you do find gypsum veins in mudstones in the middle of the UK. We've got gypsum mines not far from Nottingham, but gypsum pebbles I've personally not found, which is a shame.
Another one.
Specimens of corundum like sapphire and ruby? Personally, no. That's a shame. Amethyst is the closest I've come to that. You know, I know they're not. It's not corundum. I can't think I've ever found any corundum, to be honest. No. Can you find marble pebbles? Absolutely, yes, you can. You do get marbles. A marble technically is a limestone which has been metamorphosed, and you do get some lovely greenish minerals. You get some up in Scotland, a place called Ledmore, where you get some beautiful. There's the Durness limestone. You get some all sorts of lovely marble pebbles in this part of the world. I'm not sure I've got a marble pebble, so I'm going to have to make a trip, I think. Okay, Eloise.
I think that's all the questions I found.
Okay.
On the chat?
Yeah, the chat's got sky marble. There you go. Perfect. Sky marble is the prettiest. Absolutely. That's the one I was struggling to think of. Have you ever been to Paris Mountain? I have. I went to Anglesey, which is where Paris Mountain is, many moons ago. I have a black pebble covered in short, white, straight and curved lines, about 2 centimeters wide. Could this be coral? Ooh, well, possibly, yes. It sounds like it might be if it's curved. Because if it's straight, it's more like to be something like a basalt. But you do get black limestones, and you do get fossils in them. So yes, it sounds very like it could be maybe not a coral. It may be shells, but you do sometimes get corals. I had it here somewhere. It's disappeared in the mess of my things here. Oh, here we go. So that, for example, I'm pretty sure is a coral. It's just a scary looking rock otherwise. Okay, Eloise, I think we have. Can I join on Saturday? I've got a feeling that the event on Saturday might be fully booked, I'm afraid.
It is fully booked.
Yeah. Okay, Eloise, I think we have come to the end. I'm quite happy to stick around for a little bit more if anyone has any other questions. Thank you very much, everybody, for joining me today, and thank you very much, Eloise, for fielding the questions. If you have any pictures that you want to send me, my Twitter address is just here, Clive. It's at CliveBGS. You can send me a picture of your pebbles, and I'm happy to have a go at identifying them. I can't promise, but I can ask the other geologists in the Twitterverse if they can help us work out what they are. And you can see my map here, which I didn't show you. These are all the places that I've been to collecting pebbles over the years. So you can see, and some places that, for example, in Northern Ireland and in Wales, that some of my friends in Beaches have sent me as well. So here we go. Can fossils turn into pebbles? Absolutely, they can. So I showed you that piece of belemnite earlier, and that is, here we go. That's a fossil pebble. So that is part of a fossil. So you do get another nice one that you get, something called Gryphea, which is the devil's toenail, which is a shell that is curved round, and you find those as pebbles. They're quite common. They're actually quite nice. So I sometimes find pebbles with holes in them and lots of circular dimples. Ah, okay. Well, that could be one of several things. Pebbles with holes in, it may be that you've got a rock like this, like a lava, which has got vesicles, which are gas holes. but circular dimples, it may be that you're talking about a rock like a flint, or it may be a limestone, basically, which is the dimples could have been worn away by acid rain, because rainwater is the acid, and over the years it will wear away limestone, because basically the rain dissolves the carbon dioxide from the atmosphere and forms very weak acid. That's how caves are formed, from rainwater percolating through the limestone. They percolates through and dissolves away hollows and caves and caverns, and you ultimately end up with gorges and Cheddar Gorge and places like that because of acid rain. So, can't see your Twitter address. Well, my Twitter address is on the board behind me, and it is at Clive BGS. It's just there. So it might be a bit far away, maybe. Yes, galena does contain lead. Galena is a mineral containing lead and sulfur. Okay, Eloise. Oh, on the beach in Bournemouth, I found interesting flat round pebbles with lots of holes in. It looks like it's been eaten, but I don't believe it's igneous. I advise it could be fossilized algae. Is it possible to identify fossilized algae? You can identify fossils like that, which are formed rocks, but it may be that what you found, you do get some seashells, living seashells, that bore holes in rocks. They attach themselves onto the rock and they bore holes through them. So if you find little perfect circular holes, it may be due to that, this sort of boring sea creatures. Can you find rhodochrosite and crinoid stems? You can definitely find crinoid stems in the UK. Rhodochrosite is a form of carbonate mineral that you can find. I'm pretty sure you can find that in the UK as well. Crinoid stems are pretty common in limestone. If you go to Derbyshire or other sort of carboniferous limestone parts of the UK, you look hard enough, you will find it. Have a look on the BGS website, the Geology of Britain viewer. We also have an app called iGeology. You can download that onto your smartphone, onto iPhone or Android. This will, wherever you are, this will show you the geology of the UK. So here we go. This is iGeology, and basically, if I click on that button there at the top, this is where the BGS is located. And if I click on it, this tells you about the location and it tells you about the geology under your feet. So I recommend that you get iGeology on your phone, and then you can learn more about the geology by clicking on there, and this tells you the detail of that geology. And this pulls from the thing called the lexicon that I was telling you about earlier. So this will help you identify maybe what the cliffs are made of on the beach you are, and that may help you identify the pebble you're holding in your hand at that particular beach. What are pitocks? I think pitocks. I wonder if they are those seashells that bore holes in rocks. Maybe. We just Googled that. I'm not sure. Okay, Eloise. Anything else?
I think everything's coming up. I had lots of questions. That was fantastic. Thank you, Clive.
Okay, no problem, everyone. Like I say, I'm happy for you to get in touch with me via my Twitter or maybe via BGS. If you've got a picture, if you've got a pebble, take a picture of the pebble, email it to me, and I'll be more than happy to look at it and try and work out what it is for you. And like I said, there are lots of guides that are available. And also, don't forget, my book comes out in April. It's the Pebble Spotters Guide. If you Google that, the Pebble Spotters Guide, you'll find me, Clive Mitchell, hopefully on Google or Amazon. Okay, can metal turn into pebbles? Good question. I'm not sure. Possibly. Are there any more after Saturday? I don't think there are any more events after Saturday, Eloise.
No, Saturday's the end of the events for this time. But hopefully we'll look to do something again soon. Okay,
Eloise, I think we've pretty much run the course for the... So I'm going to say cheerio, everybody. And thank you very much for turning up. I hope you enjoyed it, and I certainly have. And collect pebbles and have a good time. And like I said, send me pictures. And okay, cool. Right, I'm going to end Eloise, okay?